The homework this week involves several functions over linked lists. You're going to find the homework in the file mylinked0, and that is located in the package algs13. In this video, I just want to walk through and make sure you understand what each function is meant to do. The first of these is going to check the size of a list. So if I have a list with 2 elements, the size would be 2. If I have a list with 4 elements, the size would be 4, etc. And you can see here in the corner case where the list is empty, the size is 0. We'll also have a function here to test the sum of the positive elements. So this is going to compute the sum of the elements but ignore the negative ones. So if I have -3, -4, -1, I just ignore those. I'm going to add instead 11, 21, 31, and 41, resulting in 104. Okay, and you can see so here for some corner cases, if there's only one element and it's negative, well then the sum is 0. That's the same as the empty list. And if I have a single element, well I just return that as my value. The next function you're going to do is a mutator. So it's changing the contents of the list. All of the other functions in this exercise are accessors. They're accessing the list without changing it. So this function will remove the first element. And so you can see the way the test is written, I have the initial value of the list, that's 11, 21, 31. And then the result after the function is called should just remove the first element. So we have 21, 31. And you can see here for some corner cases, if I have a singleton list, I will of course end up with the empty list when I delete it. And if I start with the empty list, you know, there's some choices here of what one would do. The choice I'm going to have you take is just to ignore the function. So the function will do nothing. Okay, so if you try to delete the first element of the empty list, we'll just do nothing. Succeeds, leaves the list alone. The next two functions are slightly more interesting. The first of these is going to determine the length of a common prefix of 2 lists. So you'll write a function that has 2 lists as parameters. So here's the signature of the function. It's got this list, so I'm looking at this list, and a parameter that. Okay, I'm checking whether this list is what it has in common with that. The way the test is written, this list is first, and then that list is second. So we're checking this versus that. If you're curious to see, you know, what exactly is going on, you can actually look at the test. It's the code is sitting down here, so it's not that hard to read. You can find test length of common prefix. I've got the expected result, which is an integer. I've got 2 lists represented as strings. And what I'm going to do is turn those things into actual lists and then run the code. And the way that's happening here, you can see list1 dot length of common prefix with the list2 passed as the argument. Okay, so the first one is this, the second one is that. And then what you're being asked to do here is to determine how many values they have in common starting at the beginning. So we're just going to check them sort of pairwise. We have 11 and 11, so that's good. 21 and 21, that's good. 31 and 31, that's good. Then we have 41 and 5. Oops, not the same. Okay, so the number of common things here is 3. That's the length of the common prefix. And the test here will show you what happens in various cases. So for example, if I have 11.5 and then 11.21, well, the length of the common prefix is 1. For the empty list, the length of the common prefix will always be 0, regardless of whether it's this or that is an empty list. The final function is just going to look at the even indices of the list. That's the even elements. And we're going to look to see if those elements are strictly increasing. So if I see 11, something I don't care about, then 21, something I don't care about, 31, that's increasing, strictly increasing. If I see a 5 in that position instead, that's not strictly increasing. And so I'll return false for the result of this function. And I do mean strictly increasing. So if I have a repeated value, then that's not strictly increasing and will return false. And again, in the corner cases here, the singleton and the empty list will always be considered increasing. Okay, so we'll just say true in those cases. So that's the homework problems you're set to do. They're all set in terms of a linked list. These are member functions of the list. So you're working on this list. So my size function here, note it takes no parameters. And that means that you're going to look at this first and then compute the size from there. And likewise for the rest of them. So the only one with a parameter is this length of common prefix, which I discussed before. And as usual, there's some reading up here for you to do. So take a look at the reading and good luck with the homework.